Okay, Unit 2, Day 3. We're going to do another operation. Yesterday you did addition, subtraction, multiplication, and division with functions. Now we're going to do a function called, or an operation called composition. So our learning target is I can find the composition of functions. And to start out with, let's just say, let's suppose that I wanted to plug 3 in for f of x. So what that's saying is find what is f of 3. And anytime it says f of 3, whatever number is here, that's what you plug in for every single x that you see in the function. So I have 5, here's an x, here's another x, plus 1. So I took all the x's out. Everywhere I saw an x, I'm going to put 3 in its place. Okay, and if you put that in the calculator, this equals 49. And then it says, then plug that answer, so plug 49 into g of x. So I need to figure out what's g of 49. Okay, so g of 49 would say, here's our function g, it's 10 minus 2 times something. Okay, so I took the x out, I left the space, and 49 is what I want to put in its place. Okay, and this ends up being a negative 88. And now what if I wanted to reverse the process? So what if I wanted to plug 3 into g first and plug that into f? So I'd take g of 3. G of 3 says take 10 minus 2 times something. In this case, that something is 3. And that gives me 4. Then plug that into f. So f of 4. So plug that into f. This says 5 times something squared plus that same something plus 1. In this case, the thing I'm plugging in is a number. It's 4. And that would give me 85. So notice, not the same thing. Okay, now it is cool. There are certain times where they do equal the same thing. Whatever you, so like 3, you plug in 3, you get 3. And same thing here. We would call those inverses of each other. Those are special kinds of functions that when you compose them, what you plug into one and do this trick, you get the same number back out. So that is a special thing that happens. Now, notation for this, the notation for plug a number into one, then take that answer and plug it in the next, that's what composition is. The notation for it is f, and I'll put my g, and now instead of putting if you put a closed circle, it means multiplication, so I got to put an open circle. Okay, so it looks like fog. A lot of people say that that's fog, but it's not the letter O, it's just an open circle. Okay, and what this is really saying is I'm going to take the function g, whatever you get for g, and plug it into f. So that would be sort of what I did here. I plugged a number into g, and I took that answer and plugged it into f. This is take x, plug it into g, then plug it into f. So it'd be f of g of x. That's probably the easier way of writing that. I think this makes more sense. Okay, so if I put a number here, it would say plug it into g first, get an answer, then take that answer and put it into f. We could also reverse that. We could say g of f, or g composed with f. It's two ways of saying it. So this would be g of whatever f of x is. Whatever you get when you plug it into f, get that answer, plug it into g. Okay, so here, when this says, and this is this notation over here, so this says, I'm going to take what I get when I plug 2 into f. So f of 2 would be 2 times 2 minus 1, because that's what this would take out the x, plug the 2 in, so it's 4 minus 1 is 3. So simplifying that, I get g of 3. G of 3 says take 3 squared, so that'd be 9. Okay, this guy here, I'm going to take f of whatever you get when you plug in 2. Well, when I plug 2 into g, that would be 2 squared. So that'd be f of 4. What's f of 4? We'll plug 4 into this guy, so that'd be 2 times 4 minus 1, which would be 7. Okay. Down here, I think convert this to that kind of form. So g of f is really just g of f of 6. That'd be f of 6 would be plug 6 in. So this would be g of 12 minus 1, so g of 11. G of 11 says plug 11 in and square it. So 121. This guy here looks weird. Okay, you're going to plug -3 into G, get an answer, then plug that back into G. So this would be G of -3. So let's first figure out what this is. So G of -3 would be -3 squared. Well, -3 squared is 9. And now plug 9 into G, that says squared again. So that'd be 9 squared, which is 81. Okay. So f of g of x, there's no number to plug in. So instead of plugging a number in, I'm going to plug this function. So I'm going to take f of, and what's g of x? G of x is x squared. So I took out g of x and I put x squared in its place because that's what g of x is x squared. And now plug x squared into f. F says take 2 times something minus 1. Whoops, so 2 times something minus 1, and that thing that I'm going to multiply by 2 is x squared, because it says plug in an x squared. Instead of plugging in a number, like f of 6 says plug 6 in the function, this says plug in x squared in the function. So this would be 2x squared minus 1. And over here, g of f of x, well, f of x is 2x minus 1. So this says, take 2x minus 1, plug it in everywhere you see an x. So it says I'm going to square it. So 2x minus 1 squared. Instead of plugging in -3 and squaring it, like that's a number, this is plug in a function and square it. So when I square that guy, that's just like FOIL. I'm going to multiply this out. So first, 4x squared, outer, minus 2x, inner, minus 2x, plus 1, so 4x squared minus 4x plus 1. Okay, so let's turn this over. Okay, now the back side here, well, maybe that's just redundant to do more of these. Just if you want to practice them, I'll put the answers down here. You can practice these and maybe just try 1 or 2 of these, and if you get it right, I'd say you probably understand it and can move on. So just for the sake of time, and if you understood the front side, you understand this. If you had trouble on the front side, you're going to have trouble with this. So go back and look at the front side again and then try these out. Now here, a little bit different. We're going to be doing a graph. Let's zoom out a little bit here. We have a graph, a graph and a table is how we're going to get our values. Okay, so we don't know what the function is. F of x, I have no idea what it is. Like up here, I have h of x is x plus 3. It's defined. I know exactly what it is. F of x, it never tells me what it is. It just gives me a graph. And over here, g of x, so this is g of x. I could put g of x right here even. Instead of y, replace with g of x. It just gives me a table. It doesn't. I never know what the function actually was. Okay. So on this guy, this says take f of g of -6. G of -6 says, what do you get when you plug in -6? So go to function g, which is a table, plug in -6, what came out? 0. So I'm going to replace this with 0. Now it's asking me what's f of 0. Well, this is function f, the graph. So what do I get when I plug in 0? I need to go to 0 on the x-axis. So right here is 0 on the x-axis. My y value is -1. Okay? All right, so let's do another one. So over here I've got g of f of -5. So anytime you see it written like this, just rewrite it like that. It's going to be a whole lot easier to understand. So first off, let's figure out what is f of -5. Well, f is the graph. So I go to the graph. I need to plug in -5 on the x-axis. What y value came out? It looks like 4. So f of -5 equals 4. So I replace it with 4. Now, what's g of 4? What do you get when you plug in 4 into function g? So here's g. I'm going to go down to 4. My output is 5. Okay? This guy, f of 8. So f is the graph, and I'm going to do f of 8 first. What is f of 8? So I got to go to 8. The y value that came out to that was -9, because I'm down -9 here. So this gets replaced with -9. Now what's f of -9? So I'm going to go -9 on the x-axis, that's 0. The y value is 0. Okay. This is the same thing as g of 5. So figure out what's g of 5 first. So ignore everything else. Just what's g of 5? When I plug 5 into g, it's right here. The output is 3. So I'm going to replace that with 3. Now what's a g of 3? We'll go back to function g and plug in 3 this time. My output is 7. And that's it.